All right, we still are in section 2.6, looking at limits at infinity. And quickly, I don't know if you noticed, hopefully you did notice in our last two examples, that basically when you look at the limit as x approaches infinity or minus infinity of a function, and you find out it's a certain value, say b, that is actually a horizontal asymptote of the graph of that function. So if you're asked to find the horizontal asymptotes, and here in example 20, find the horizontal asymptotes of the graph of f of x equals x cubed minus 2 over the absolute value of x cubed plus 1, then what you're going to do is use what we've learned as far as finding the limit of such a function and see if it has asymptotes. So when x is bigger than 0, so as x is going to positive infinity, we look at the limit of this function. I can just drop the absolute value of x because the absolute value of x is just x when x is bigger than 0. So I get this rational function, x cubed minus 2 over x cubed plus 1. And we learned that I take the highest power of x, in this case x cubed, so with the highest power of x that I see in either the numerator or the denominator, and I multiply 1 over that highest power of x in both the numerator and the denominator. So after simplification, this becomes 1. So we have a horizontal asymptote at y equals 1 as x approaches infinity. For x less than 0, in other words, x approaching negative infinity, now when I take the absolute value of x, it becomes the opposite of what x is. So I have to replace this absolute value of x with minus x. And then when I cube minus x, it becomes minus x cubed. So now looking at this rational function, again, the highest power of x I see is x cubed, multiply the numerator and denominator by 1 over that highest power of x, simplify, take the limits, and I get minus 1. So the horizontal asymptote for x less than 0, in other words, as x approaches minus infinity, is y equals 1. So we have two horizontal asymptotes, one at y equals positive 1, one at y equals negative 1.